Hello everyone. In the last video, we have already discussed what is perceptron and how the scientists build this from biological neuron to some mathematical structure. All these things we have discussed in the last video. And now let's see how this perceptron can be used in some machine learning model or in order to solve some machine learning use case. Okay. So here if you observe, this is the equation that is output equal to f of summation of xi wi. Okay, so this is the equation that we'll be getting out of this particular perceptron, and if we expand this, it will look something like this. So output equal to f of x1 times w1 and similarly x2 times w2, so on, like that. How many ever inputs that we have, let's say xn, those weights will be associated with that, and finally our equation will be looking something like this. Now if we carefully observe this particular equation, have you guys seen this before in my videos in any other form? So basically, if you remember, what is the hypothesis of linear regression? So we already discussed there are three steps, right? First one is hypothesis, and then loss function, and then optimizer. So when it comes to linear regression, the first step, that is hypothesis, is equation of a straight line, and that will look y equal to mx plus c when there is only one specific feature that we are having. Let's say if you are having n features, then how my equation will be looking like? My equation will be looking something like this, that is theta naught plus theta 1 into x1 plus theta 2 into x2 plus theta 3 into x3, so on, theta n into xn. If you observe this equation and this equation, both are almost similar. So the only change over here is, instead of theta 1, here we are having w1, and similarly here, instead of theta 2, we are having w2. Like that, instead of these thetas, we are having weights over here, and similarly, like here if you observe, there is no w naught, but here we are having theta naught. That is one difference that we will observe. And remaining, if you see, this is output and this is y, that is just the representation. So you can see that almost these two are the same. Only thing is that it is passing through some function, whereas this equation is not going through any of these functions. And if you see, theta naught is not there. And if you remember carefully, in linear regression algorithm itself, we have discussed that this particular theta naught is having some significance. And if you remember, that significance is that, like if you take simple equation of y equal to mx plus c, what is this c representing? This c is representing the y-intercept where it touches the y-axis, right? Similarly, here also, if we have w naught, then that will help actually. So it will be providing us more information. That's why these scientists add up some new weight for each and every neuron that we are having, and that weight will be something like w naught, or it can be also called as bias. Okay, so this extra w naught weight can also be called as bias in case of perceptron or in case of neurons. Okay, please remember this. And like as I said, now it is exactly the same. For w naught we have theta naught, and for theta 1 we have w1, and for theta 2 we have w2, so on for theta and w1. The only change is we are having this specific function over here. And what should be this function in order to make it exactly equal to the linear regression hypothesis? The function just needs to be something linear, right? So, and what is that linear function? Like if we are passing f of x, then the output should be x. Like here we are passing this equation, right? That is f of w naught x1 into w1, x2 into w2, so on, xn into w1. In order to make it exactly equal to like linear regression hypothesis, we should use this specific linear function. This is also called as linear activation function, and our hypothesis will be same as the linear regression hypothesis. Okay, and with the help of linear regression hypothesis, what kind of problems can we solve? If you guys remembered carefully, we can solve all the regression problems, right? So regression problems can be solved by using this perceptron. Okay, so using perceptron we can solve regression problems. And what should be the activation function in case of this? The activation function should be linear activation function. Now, if you guys remember, we have already discussed logistic regression as well. In logistic regression, what is our hypothesis? If you guys remember, the hypothesis of logistic regression is y equal to sigmoid of the same linear regression equation, that is theta naught plus theta 1. This whole thing will be coming over here, right? So this is my logistic regression hypothesis. Now, if you see, this is also similar to this one, right? So this is also very similar to this one. Only changes, instead of this function, what are we having over here? We are having something called a sigmoid, and this is also a activation function. Okay, so for solving what kind of problems can we use this activation function? Basically, in logistic regression, what kind of problems can we solve? If you guys remember, we can solve something called as binary classification problems, right? So in order to solve these binary classification problems, simply if we can use this particular activation function, that is sigmoid, then we can be solving those kind of problems. Okay, so in order to solve binary classification problems, we can use sigmoid activation function. So like that, perceptron can be used in order to solve both regression, and also we can solve binary classification problems. Okay, so I hope like this is very clear how the perceptron can be used. In the next video, we'll be seeing how these will form some layered structure and form one big neural network. Okay, so I hope you guys are liking this video. Please do like, share, and subscribe. And thank you everyone. Bye bye.